Hello, students. So today we're going to go over some of the problems that, as a class, as a whole, struggled with the most on the My AP multiple choice problems on review week 1. So here's the first one. Question number 2. It says, which of the following functions of x is guaranteed by the extreme value theorem to have an absolute maximum on the interval 0 to 4, and it's including 0 to 4 because that's closed interval notation. So extreme value theorem. So if you remember extreme value theorem, the function must be continuous. So here I give you the flashcard, the theorem for extreme value theorem, and it says that the one criteria for the extreme value theorem to work is that the function must be continuous. So if it's asking for an absolute maximum, then you would want to go through each one of these and just make sure that it's continuous. So if I go to A, tangent x has vertical asymptotes at pi over 2, and it has a period of pi. So the next vertical asymptote would be at 3 pi over 2, 5 pi over 2, and so on and so forth as you continue to positive infinity. If you were to go to negative infinity, the next one would be negative pi over 2, negative 3 pi over 2, and so on and so forth. In any case, there is a vertical asymptote, which means that there is an infinite discontinuity at pi over 2, which is on the interval of 0 to 4. So therefore, A cannot work. Now, the next one, B, is tangent inverse. So if you remember the graph of tangent inverse, or if you don't, then you can think of A, the graph of tangent x. Well, the graph of tangent x, the domain, if we're just doing the function, is going to be from negative pi over 2 to pi over 2. And the range would be negative infinity to positive infinity. And I'm sorry, I meant if you want to do an inverse function. So therefore, it needs to be 1 to 1, which means it has to pass the vertical line test and the horizontal line test. So if you take that portion of tangent x and you reflect it over the y equals x line, then the domain and range will switch, which means you will now have horizontal asymptotes at pi over 2 and negative pi over 2. And you're not going to have any vertical asymptotes. The range of A, tangent x, was all real numbers. So that means now the domain of tangent inverse x is all real numbers. So therefore, this function here is continuous for all reals, which means it is going to be continuous on the interval of 0 to 4, including 0 and 4. C has vertical asymptotes at x equal to 4 and x equal to negative 5. So since it has a vertical asymptote at 4, you know that it's not continuous at the endpoint 4. And then the last one, D, there's a vertical asymptote when x equals to 0, because that will make e to the 0, 1, 1 minus 1 will be then 0, and so you're dividing by 0. So again, it's not going to be continuous on the endpoint 0. So then that means the answer is B. So you were looking for, in order for the extreme value theorem to work, the function has to be continuous on that interval. The next problem, question 5, it says the table above gives values of a function g at selected values of x. Which of the following statements, if true, would be individually sufficient to conclude that there exists a number c in the interval negative 2 to 2 such that g of c equals 6? So before I look at any of these options, right now, by the way they're asking the question, I know that I have to be applying the intermediate value theorem. So if I know that, then let's think about intermediate value theorem. Intermediate value theorem says that, well, the first criteria must be that it must be continuous on the interval that we're talking about. Then, once we know if it's continuous, then the y value that we're curious about, which is 6, has to be in between y values on this interval. So if I look at each of my options, 1, 2, and 3, it says g is defined for all x in the interval. Well, if we know that it's defined for all x in the interval, that means that every x on the interval of -2 to 2 has a y value. But that doesn't necessarily mean it is continuous on the entire interval. It could have a jump discontinuity and it still satisfy that every x on that interval has a y value. So g, it's saying that it's increasing. So again, that doesn't necessarily mean that the function is continuous on the entire interval. So what is the last one? In order for this to be true, what would be sufficient enough to conclude this would be 3. Since it says that the function is continuous. So now that we know that the function is continuous, then I can go and look at the table and I can go, okay, well, let's see. The endpoint, the y value is -4, which is less than 6. And the right endpoint, the y value is 20, which is greater than 6. And 6 lies in between -4 and 20. And you could probably even zero in on this interval 0 to 1. But although it says that, at least one number c, you don't know what happens in between these values, if it went above or below. But you know for sure there's got to be a c in between 0 and 1 that would, f of c would equal 6. And there could be more. But the fact that this is continuous and the y values on the right endpoint and the left endpoint are greater and less than 6, then that would be sufficient. And so the answer would be B. And the last problem that we struggled with was number 6. So it said, let f be a twice differentiable function. Selected values of f prime and f double prime are shown in the table above. Which of the following statements are true? So when I look at this, they're showing me values of the first derivative and the second derivative at selected values of x. Okay? And as I look through my options really quickly, they're talking about relative minimums and maximums. So they're talking about relative extrema. So if I'm given the first derivative and I'm given the second derivative and they're asking about relative extrema, then most likely what they want us to do is apply the second derivative test. So here's our second derivative test, which is on a flashcard. And this is saying that, well, if your first derivative equals 0 at c, and it's greater than, then you've got a relative minimum. If it's less than, you've got a relative maximum. If it's equal to 0, then the test fails. You have to do first derivative test. So let's see. They're talking about 1 and 4, probably because our table shows that at 1 and 4, the first derivative equals 0. So if I look at that, the first derivative at 1 is 0, and the second derivative at 1 is -2, which means that second derivative is negative, therefore it's concave down. So by the second derivative test, there exists a relative max at x equal to 1, which means then option 1 would be no, because it says neither a relative minimum nor a max. And option 2, yes, because it does say that it's a relative max. So now let's look at f prime of 4. F prime of 4 is equal to 0, and then they also tell us f double prime of 4 is positive because 1.2 is a positive value. So therefore, it is concave up. And so by the second derivative test, it has a relative minimum at x equal to 4. And 3 is saying that it has a relative maximum, which we know is not true, according to the second derivative test, which means B is the answer. So I hope this clarifies some of your questions on this My AP questions that we had. Thank you.